We'll get done. All right, so we're going to talk about inverse functions. Okay, inverse inverse is like reverse. It does backwards. Okay, if you're talking about an inverse function, it's what inverse functions do is they swap the domain and the range. So they swap x and y, and that's what we'll talk about here. So swapping x and y. So inverses swap x and y. Technically, the technical definition is it inverts the domain and the range, so just exchanges those. But it swaps x and y, and that's how we're going to do that. So what we're going to do is we're going to find the inverse for a function. Okay. So let's just start with example A. F of x is equal to 3x plus 4. All right, so there's a few things that have to happen for us to even be able to find an inverse for a function. A function, in order to be invertible, or so that you can find an inverse function, is it's got to be what's called a one-to-one function. Okay, so one-to-one function. Just a second. Mute that. All right. A one-to-one function passes the horizontal line test. Remember back maybe in Algebra 1 and a little bit earlier in this class, we talked about deciding if something is a function or not. And if you've got the graph, the best way to decide is the vertical line test. And if it only touches in one spot, then it passes the vertical line test. But if it ever touched in more than one spot, it failed and it wasn't a function. The horizontal line test is the same idea. You look at a graph and, so you've got this particular graph, the 3x plus 4, that's a line that does something like that. It's a line. If that passes the vertical line test, it's a function. We already know that because it's in function notation. But it also passes the horizontal line test because I can put a horizontal line anywhere on that graph, and it's only going to touch it in one spot. So that's kind of one of the stipulations that you've got to look at before you find the inverse. You got to say, okay, well, can there be an inverse? If it isn't a one-to-one function, it doesn't pass the horizontal line test, then you can't find the inverse. Okay, and it doesn't have it may have an inverse, but it's not a function. And what we're looking for are functions that their inverses are also functions. So that's where the horizontal line test comes in. This one passes it, so we can go ahead and find the inverse of this. So inverses swap x and y. What part of that function is y? F of x, that's right. Good job. All right. If inverses swap x and y, that's what we're going to do. We're going to swap x and y. Then we're going to solve for y again. And that's going to give us the inverse function. I would subtract 4. And then what do I do to get y by itself now? Divide by 3. And I'm just going to divide everything. That's 1/3 x minus 4 over 3 is equal to y. And if we're going to write that in inverse function notation, we started in function notation, f of x. The inverse is written like this. F inverse of x. It's like a -1 exponent is what we write it like, but we read it f inverse of x is equal to that. Those two are inverses of one another. Not very difficult. That's a pretty easy one. We're going to get to much more difficult. That means inverse. F to the f negative 1 exponent is how you write it, but it's f inverse is how you read it. Okay. Because that's the inverse. That's what says inverse. That's the notation for inverse, is that negative 1 exponent. Okay. It's kind of like a reciprocal, like 2 to the negative 1. The inverse of that is, or 1 to the, move the 2 to the bottom, get 1/2. That's the inverse of that. That's what inverting does in math. So this is the notation for inverse. It's not a negative 1 exponent. It's the notation for inverse. It's kind of in this chapter with all these exponents, so we kind of think exponent, but it's notation for inverse is all that is. Okay. All right, so let's look at one that's maybe not quite as straightforward. Example B, f of x is equal to x squared, and then they tell us that x has got to be greater than or equal to 0. The reason they tell us that is because of the graph of the x squared function, which is quadratic, right? So its graph is a parabola. Normally looks like that, right? What does the x greater than or equal to 0 do to it? Well, it doesn't make it go. It means which part of that? The part where x's are greater than or equal to 0, which would be the right side or the left side of it? The right side. So what that x is greater than or equal to 0 does, it takes that part off, and now that passes the horizontal line test, which allows us to find the inverse.
But I thought it had to pass just one time. It is passing just one time.
It does now, but it didn't. It didn't when it had that there, because I could draw a horizontal line right there, and it crosses it twice.
Okay.
So by the x greater than or equal to 0, when we take that half off, now it's only touching once, so I'm good. I can find the inverse.
Like the x-axis.
Not the x-axis, but the just a horizontal line at anywhere on the graph. Anywhere on the graph is where that would go. So we can find the inverse of that. So let's do that. We'll change that to y and x squared. Inverses do what? Swap x and y. That's right. X equals y squared. Now, how do you undo squaring? Take the square root. And I'm going to put the 2 index there because we're going to get some that's not a square root. Maybe it's a cube root. Maybe it's a sixth root.
How did you know to put y equals x squared?
F of x is the same thing as y. That's.
You told me that like 3 times.
Kegel told us that the first time. All right. Give him credit. Say something. Now.
It's not that I don't know it. It's just an insult.
All right. So now here's the thing we got to watch out for. When we take the square root, it's an even root, so we've got to have plus or minus in front of it, right? We should. Now, which one of those is the right one? It stems back to this. X is greater than or equal to 0. On our graph, what are the y values like here? They're all positive, so we want the positive side of that. Okay, so that's what we've got to be able to think about graphs a little bit here. Not necessarily have to graph anything, but we want the positive side of that, not the negative side. So I'm gonna leave both of them there for the moment. And then when I write it f inverse of x, I'm only going to use the positive square root of x as the inverse for that, because the y values in the original function were positive. Okay, it makes a difference with this. Let's look at. See. All right. Let's say we had the function g of x is 1 over 27 x to the third, and we want to find the inverse of that.
Is that x to the third
That 3 on that x is an exponent, yes. 1 over 27 and then times x to the third. That's what that function says. Okay? Now, what's the graph of that look like? Because we need to decide, does it pass the horizontal line test? So I'm going to graph that. And I'll do this one with the calculator because I'm not really good at drawing the cubic curve at all. So I'm going to go to y equals on my calculator. I'm just going to type in 1 over 27 x to the third. And make sure it passes the horizontal line test. It gets pretty flat right here in the middle, but it's not perfectly flat. If you zoomed in there, and I'll show you, this is another reason I wanted. Right. Because then the horizontal line would touch more than one spot. It's kind of like this remote's straight, right? So if I lay it on this table, it's touching everywhere, so that's more than one spot. So it can't touch more than one time.
I thought it had to come off and then come back on.
No, it doesn't necessarily have to come off and come back on. It's like lay the remote on the table, lay it there. It doesn't matter if it's touching in one spot and then another, or just if it's got two spots real close together there. Okay. So the more I zoom in, the more you see that it doesn't. It's not perfectly flat. You can see, I'm really close. Yeah, there's a little. The resolution's not the greatest in the world here, but there's some space there that it's going to. Zoom 6. Back to the original of that. But it passes the horizontal line test, so that means we can find the inverse of that, and there's no stipulation out here beside it that says x is greater than or equal to 0 or anything like that. If there is, then you've got to look at that part of the graph. This one, they don't tell you that because it's a function no matter what, and it passes the horizontal line test, so there's nearly no rules that it breaks. So y equals 1 over 27, x to the third. How do I get the inverse? Yeah, swap your x and y first. Or you can do it last. It doesn't matter. I do it first. Either way, they got to be swapped. Either first or very last. Never in the middle. Okay, so let's get y by itself now. So what do I do? Yeah, multiply by 27 or divide by the 1 over 27. That's the same operation mathematically. So that's 27x is equal to y to the third power. Very good. So the opposite of cubing something is the cube root. Good. Why does it turn into 3 cube root of x? Yeah, and there was a breakdown to 27 like we did last week or this whole last week, and 3 comes out, nothing left inside. And then, so we're going to rewrite it in function notation. It'd be g inverse of x is equal to 3 cube root of x. So inverse.
If we don't put that negative one, we're going to get it wrong.
If I ask for it in inverse for an inverse function, yes. Yeah. I won't be as picky on that as I would be at the -1 thing there. Yeah. And I just used the g of x. It's just to name it something different. Let's do this one. H of x. Changing the letter here. 2x to the 5th plus 3. And we want to find the inverse of that. Not 5th squared, but 5th power. Bless you. And I'm going to swap x and y. And then get y by itself. How do I do that? Yeah, -3. X minus 3 is equal to 2 y to the 5th. Divide by 2. That's good. So x over 2 minus 3 over 2 equals y to the 5th. Or 1/2. Yeah, you could write it as 1/2 x or x over 2. Those are the same thing. Okay. So how do I get rid of the 5th power? Take the 5th root. Do I need the plus or minus in front of this? Why not? Because it's not even. Only time you need the plus or minus is when it's an even root. So there's y, and then this is 5th root of x over 2 or 1/2 x minus 3 over 2. Go to function notation, h inverse of x. Same old stuff. Not bad at all. It really doesn't get any more complicated than those. I mean, there's different roots and things, but nothing any more complicated than that. So, here's done. It's on page 442 is where it starts. Let's do 3 through 11, and then 23 through 43. Odd on both sets there. Okay. Now, when you look at 3 through 11, it's these are linear functions or linear equations. They just want you to find the inverse of those. Find the inverse of those. That's like example A. When you get to number 23, it's the inverse of a power function. That's like example B, and then or B and C. And then when you get to 30 or when you get to 29 through 37, it says graph the function f. You can do that on your calculator. I'm not saying you have to draw it on a piece of graph paper. Then use the graph to determine if it whether the inverse is a function. So what test are you using on that graph? Which line? Horizontal line test. If it passes it, yes. If it doesn't pass it, no. That's those. Then 39, 41, and 43, it's find the inverse again. That's like example D. Got an hour.